I'm a little bit sick, so my voice will sound a little bit off, but let's go. How urbanization and renewable energy impact CO2 emissions. And I'll be talking about how urban growth and green energy shape our planet's carbon footprint. The introduction. What is the goal? So I'm investigating how CO2 emissions are connected to two big global factors: urbanization rates, shown in percent of people living in cities, and renewable energy use, shown in percent of energy from green sources. Why does this matter? Cities are growing fast, and this growth may come with environmental consequences. Renewable energy is key to fighting climate change, so understanding its impact is important. My hypothesis. Urbanization. As cities grow, emissions tend to rise. Positive correlation. Urban areas often mean more energy consumption and mean also more pollution. Renewable energy. Using more green energy helps reduce emissions, which is negative correlation. Higher focus on renewables leads to cleaner and more sustainable energy. And here are my three graphs showing my countries, which I used: the United States, China, India, Germany, Canada, Australia, Russia, Brazil, the UK, Japan, South Africa, France, Italy, Mexico, South Korea, Saudi Arabia, Turkey, Indonesia, Argentina, and Nigeria. And here's the urbanization rates and the renewable energy source. Data and variables. What data am I using? A data set that includes urbanization rates, renewable energy percentages, and CO2 emissions per person for different countries. Data was collected by removing incomplete entries. Variables I analyzed. And the independent variable 1 was the urbanization rate in percentage. The independent variable 2 was the renewable energy use in percentages. And the dependent variable was CO2 emissions in metric tons per person. Urbanization rates, key status. So 67.9% average urbanization. Most countries have moderate to high urbanization, but a few are below 50%. The data is slightly skewed left. This means more countries are highly urbanized. Renewable energy use, key status. 15.8% average of renewable energy use. What's interesting, most countries don't rely much on green energy yet. The data is skewed right. A few countries are leading the way, but many still depend heavily on fossil fuels. CO2 emissions, key status. So 7.3 average emissions per person. Most countries fall below the average, but a few major outliers. High emitters pull the data to the right. This reflects inequality in global emissions. Some countries pollute way more than others. Urbanization versus CO2 emissions. What did I find? The correlation. Moderate positive R is equal to 0.454, and the regression line is Y equals 1.31x plus 65.6. What does this mean? And as urbanization increases, CO2 emissions tend to rise. For every 1% increase in urbanization, emission increases by 1.3 tons on average. The renewable energy versus the CO2 emissions. What did I find? Correlation. Moderate negative, which is R equals negative 0.432. And the regression line is Y is equal to negative 0.94x plus 22.3. What does this mean? More renewable energy means fewer emissions. For every 1% increase in renewable energy use, emissions drop by 0.94 tons on average. And here are my two graphs that I worked on. The first one showing urbanization rates percent versus the CO2 emissions in metric tons. And the second one showing the renewable source versus the CO2 emissions. The challenges I faced during this assignment. So data collection was hard at times. Some countries had missing or incomplete data, so I had to remove them. The unexpected results, the correlations weren't as strong as I thought they'd be. Some outliers threw off the regressive lines. The lessons, data doesn't always match your predictions, but that's the part of learning, is what the big takeaway I took from this assignment. Thank you for listening. That was my presentation.